Greetings and welcome, internet friends. Me and my G-Amigos here. We're talking about like proofs about geometry and the angles. We learned things about like linear pair postulate that angles that form a line are supplementary or add to hundo 80. Yep. That's a thing. That's a thing. Oh, students show me. Yeah, I get so excited when students do their quest. Man, this is good stuff. So linear pair postulate, two angles that form a linear pair are supplementary, add to 180. Vertical angles theorem, two angles that are vertical angles are congruent. And we also learned about congruent supplements theorem. The what? All right, let's take a look at this. It says identify the pairs of congruent angles in the figure. So I'm going to say angle NSM is congruent to angle PSQ. Why are those two angles congruent? Well, their measures are equal. Sounds like def of Kong. Yeah, if they're both got the same measure, they got to be congruent. But I have a pass already. All right, how about these ends? Watch this trick, right? I'm going to say angle NSP is congruent. Oh, that's a weak equal sign there underneath the congruent hat there. QSR. And these two things, notice both of them are complementary with a 50-degree angle. You guys agree those blue angles are complementary with the yellows? Because they're both complementary to the same angle or congruent angles, they must be congruent to each other. That's a long way to say congruent complements theorem. All right, congruent complements theorem. Two angles that are complementary to the same angle will be congruent to each other. So that's the reason that's true. Let's keep scrolling. Here we go. So this batch of questions used the same diagram, but had multiple pieces of information that could not have simultaneously been true, just so you're aware. So measure angle 2, let's say measure angle 2 happened to be 34 degrees. Then I have a feeling measure angle 4 would be 34 degrees. Why is that, friendos? Yeah, that's the vertical angles theorem. They didn't ask us to tell them, but hey, we might as well practice while we're here. And I have a feeling angle 1 and angle 3, they're going to be congruent to each other. How could I find their measure? See, measure angle 1 plus 34 equal to hundo 80. Measure angle like 146. Did I do it? No, I think I'm done. Yeah. Vertical angles theorem. Yeah. So I've got measure angle 1 equals 146 and measure angle 3 equals 146. So the way I would have known that, this is true because 1 and 2, or 1 and 4, or 1 and 2 formed a linear pair, therefore they're supplementary. So this was true by the linear pair postulate. You didn't have to specify in this problem, but we're here to learn and do the math, so might as well get it for free. And then, yeah, subtract both sides, bam. So kind of LPP was why this one was true. And once I knew one of them, I knew the other also had to be the same thing by vertical angles theorem, or I could have LPP'd it to the same angles like. All right, let's keep cruising. Oh, this is a problem. There's your problem. Here we go. I'm excited about this one. All right, so I've got a classic intersection of two segments, and there's going to always be some vertical angles that form and some linear pairs that form. I've got expressions that have both x's and y's in them. I could do this the hard way or the easy way. I'm going to do it the easy way by comparing x's to x's and y's to y's whenever possible. So notice this expression here, both of them have x's in it. I can equate those two things. 10x minus 4 equals 6 parentheses x plus 2. The reason that's true is vertical angles theorem. Those were vertical angles of one another. So let's solve this. I could do some distributing. I'm going to speed run this. You guys are algebra experts, of course. And if not, you go check out my other playlist on Algebra 1 content. Good stuff. Just, hey, you're already on the YouTubes watching this. Why not? Then I could probably subtract a 6x from both sides. Yeah, you're gonna have to do some algebra and your geometry tests tomorrow, just so you're aware, friendos. Oh, what am I doing? What am I doing? Yeah, yep. And 12 is left. I would probably add 4 to both sides. Bunch of different ways you could do the algebra. You guys are all well-trained algebruddies. Know what you're doing. Know how to wield the power of algebra. Bend it to your will to conquer math. Yeah. Bam, I found out x equals. So now about that y. A couple ways I could set it up. Let's we'll compare y's to y's here. This angle and this angle, those are vertical of one another. So I could have something similar. I'll fit it a little bit offset. 18y minus 18 is going to equal 6y. Right, I could have done that. Technically, a third way, I could have used this fact, and I could have done like a linear pair between these two, thrown this in x, said 10 times 4 minus 4, plus 16y equals 180. But yeah, we'll just do it. So bring the y's together. Normally, the bigger one to the little one, but it'll save me a step this time. I'll just have to deal with a negative. Negative 18 equals negative 2e. And to get rid of that negative 2, I got to divide by it because it's being multiplied by y. Yeah, we're cruising through this, but like I said, you guys know your algebra. So 9 equals y, or y equals 9 if I use the symmetric property. Ooh, actually, you know what? Here we go. My internet friends don't usually get to see me live. I'm going to try it. Here we go. Whoa, internet friends. Hi, I did this gesture right here. I said symmetric property. I'm allowed to change the order. Hi, internet friends. The channel's not about me. That's why my face isn't on this. It's about the math, right? It's about the math. It should be called Math Waddy, right? Not Waddy Math. Really. Who am I? Who am I? So here we go. Let's get the math back into here. No one wants to see me. They're here for the math. All right, let's keep going. So I found that x and y. Bunch of different ways you could have done it. Let's roll it. Got some proofs for you. You better believe it. So this is a paragraph proof. A little cray-cray right there. That's fine. Let's see what's happening. So I'm trying to prove the congruent complements theorem. I've got some given information, and this is fill in the blank. You won't have a question like this on your test, manana. Don't you worry. But the logic is still true. So if there are, if these guys are all complementary, then by the definition of, I'm going to say complementary angles, complementary, they add to 90, right? And who else adds to 90? Measure angle 1 plus measure angle 3, right? Right? Yeah. Right? Def of comp. Those things are going to add to 90 degrees. And then it says by the blank, the M1 plus M2 is equal to the M1 plus M3. What they did there? It looks like they took this and set them equal to each other. For this line? Transitive property, I think. You could make the argument for substitution as well. This is what it's saying. If this equals 90 and 90 equals that, therefore they're equal to each other, that's transitive property of equality. Trans prop equal. If you did this on the big ideas, by the way, you'd find out that sometimes these problems are just drag and drop sort of thing. And then it says by the subtraction property of equality, something. True. Okay. Well, so subtraction, how could I use this step and maybe subtract something? Both sides of that equal sign? What do you think I should subtract there? Minus angle 1, man, international geometrician right here. Which actually, I mean, mathematics is a universal language. So yeah, so I'm going to say measure angle 2 equals measure angle 3, because I could have subtracted that from both sides. Subtraction, property of equality. And then, if I know their measures are equal, then the angles are congruent by the def of... Oh, man, I almost nailed this problem perfectly, but no, it was the wrong color. Definition of congruent. So the logic is the same. Paragraph proof, 2-column proof, right? You're still making the same logical argument. See, I think I've got one more problem for you. Internet friends, do you want me to do one more problem here? The audience is going wild. They're adding comments below. They're liking and subscribing. They're releasing reply videos right now saying, please, Waddy Math, give us another problem. And I'm like, all right. Go. Reddit is going crazy right now. I don't even know. I didn't even know there was a Waddy Math Reddit. All right. Question 20. Here's a 2-column proof. Fill in the blank variety. You guys are pretty good at this one. Oh, it's actually going to be quite similar to the other one. This one was congruent complements theorem. Complementary angles add to 90. This one is congruent supplements theorem. Supplementary angles add to hundo 80. Right. So, okay, let's take a gander at this, shall we? So I've got some given information. We know how to given. It looks like these two combined say this, all right? So if these two angles are supplementary, then they add to 180. If these two angles are supplementary, they add to 180. But why is that true? Well, yeah, it's def of sup. Right? Def of sup. If the angles are supplementary, they're add to 180. And that definition works backwards as well. If the angles add to 180, then they are supplementary. Right? Definitions are biconditional, either direction. Ooh, here we go. They're claiming they're using a transitive property here. And something's going to equal 3 plus 4. What do you think that thing is? Wow. Internet friends, this is amazing. Like, proud. I promised I wouldn't do this for the views anyway, of, you know, a video in which I'm crying in it, like, and then like the screenshot of like, man. Yeah, whew, all right. But, you know, if I get one of those videos with the drama or the emotions in it, you know, I'm just harvesting. That's all. But no, I am seriously proud of my. All right. Okay. All right. Okay. All right. Def of Kong. Where is this thing coming from? Where did that show up? Does anyone know what row that's pulling from? Well, no. They've already told me why. It's actually pulling. It's a late addition, right? Sometimes people like will take their givens and then write down as much true things about their givens as possible. Sometimes it's nice to like hold that card back, let your gonna win, and then suddenly wah, right? And then they all get surprised. So yeah, we just had it show up at the most opportune time right here. So okay, and then they claim some substitution's gonna happen. The substitution is gonna result in me having, oh, this is the same as that. Do you think I could substitute something in this part? Give me something new? What can I do? Well, I think if 1 and 4 are the same, I think I could plug that in right here. Although, is this helpful? Yeah, it is. Okay, I see it. Measure 3 plus measure angle. All right. Nope, I just wrote it wrong, guys. Measure angle 1, I'm sorry. Stop the tweets, internet friends. Okay, I fixed it. Whew. All right. So, and what's, how could I get from here to here? Well, it's similar to this, except what's gone? Fraction. Fraction property of equality, yeah. And, oh boy, I think I know how this problem is going to end. Yeah, I got to pick a color that I haven't used. I'm gonna show, how about this? Yeah. All right, so how can I go from here to here? Now, actually, oh, you guys should definitely know what's going to go there. It's the last line of the proof. So it should be the thing I'm trying to prove, right? So even if I didn't know why, I should be able to at least fill that in. That's a sad looking. And the reason it's true is correct there is def of Kong, right? Def of Kong. Because if the measures are equal, the angles are congruent. Measures are. Let's see. Well, internet friends, it won't always end with def of Kong. For real life friends, Geomigos, I'm in the little video in the corner right now. You can't. But it's not always going to end with def of Kong, but sometimes it does. But def of Kong, like many definitions, it works either way. The original and the converse are going to be true. It's biconditional. So whenever I'm converting from quality to quality, you can bet def of Kong's showing up. Well, thanks for hanging out in it. Ready for our test.